Welcome to The Explainer. Today we are diving into a really wild idea. What if Einstein's theory of gravity, one of the absolute pillars of modern physics, could actually be derived from the fabric of empty space itself?
Okay, so we've all heard that classic analogy, right? You put a bowling ball on a trampoline and it creates a curve. That's kind of how massive objects warp the fabric of space-time, and that curvature tells other things how to move. But what is that fabric? What is the stuff that's actually bending?
So to really get to the bottom of that question, we first have to take a look at Einstein's original picture of gravity. His theory of general relativity, it's a masterpiece, but it also leaves us with a kind of an unfinished puzzle.
General relativity, or GR, completely upended our old understanding of gravity. It showed us that gravity isn't some invisible force just pulling things together. Nope, it's the actual geometry of the universe, bending and warping whenever mass and energy are around.
And this little thing right here? This is the elegant engine behind it all, the Einstein field equations. Now, don't worry about the Greek letters and symbols. What's so important is that this single line of math has been proven to be incredibly precise. It predicts everything from the tiny wobble in Mercury's orbit to the existence of black holes and even those ripples in space-time we call gravitational waves.
And yet, for all its amazing power, GR has this gap. It gives us the rules for how space-time behaves, but it doesn't give us a physical explanation for what the underlying medium is. It describes the motion, but not the ocean.
And that gap is exactly where a new idea comes onto the scene. It's called dynamic vacuum field theory, or DVFT for short, and it proposes a pretty radical answer. The vacuum of space isn't empty. It is the ocean. It's the physical stuff we've been looking for all along.
Now, this is a huge shift in how we think about things. The old view basically treated the vacuum like an empty, passive stage where the whole drama of physics just plays out. This new view, it suggests the vacuum is the stage, an active physical substance that's underneath everything. So the theory uses this equation to model the vacuum as a complex scalar field. Look, let's not get lost in the math here. Just think of this as a kind of instruction manual for describing the key properties of the vacuum at every single point in space.
And it basically breaks the vacuum down into two main properties. First, you've got its amplitude, which you can kind of think of as its density, or maybe its stiffness. And second, you've got its phase, which is like the vacuum's internal rhythm, its pulse.
Okay, so if the vacuum has this stiffness and this rhythm, how in the world does that create gravity? Well, this is where the theory gets really cool, building gravity from the ground up.
Here's the big idea. In this new model, matter isn't directly bending some abstract geometric fabric. Instead, it's interacting with and disturbing this very real physical vacuum field. It's creating ripples and compressions inside of it.
Now, the authors of this theory show that under certain settings, we're talking about situations where the disturbances in a vacuum are pretty gentle. Like the ones in our own solar system, something pretty incredible happens.
Under these kinds of everyday conditions, the really complex math describing the ripples and the stiffness of this vacuum field, it simplifies way down, and it becomes completely indistinguishable from the math of Einstein's general relativity. The two pictures just become one and the same.
And this leads to a pretty profound conclusion. It means gravity isn't fundamental. It's what's called an emergent property, a big, large-scale effect that comes from the collective behavior of this deeper underlying vacuum field. It's kind of like how temperature isn't a property of one atom, but it emerges from the motion of trillions of. So if this theory actually holds up, it does way more than just give a backstory to Einstein's work. It could potentially solve some of the absolute deepest puzzles in all of physics.
For one, it gives us a physical mechanism for how gravity actually travels, as a wave moving through this vacuum field. It also offers this tantalizing bridge between the two great pillars of physics, general relativity and quantum mechanics, by suggesting they both might grow from the same soil, the vacuum itself.
And it might even explain some big cosmic mysteries. For instance, take the bizarre rotation of distant galaxies. They spin so fast it looks like they should just fly apart, which is what led scientists to come up with the idea of an invisible, dark matter holding them all together. Well, DVFT suggests a totally different alternative. In the really extreme conditions out near the edge of a galaxy, the vacuum's behavior might become nonlinear, which basically means its response isn't proportional to the force acting on it anymore, and this could create extra gravitational effects. In fact, the paper claims there's about a 90% confidence from the data we have that this vacuum effect could explain galaxy rotation without needing to invent dark matter at all.
So this theory just flips our entire understanding of space on its head. It suggests the void isn't a void at all, but a dynamic, physical field whose properties literally give birth to the laws of gravity. And that leaves us with a final, fascinating question to think about. What if the thing we call nothing is actually the source of everything?